Hi there, my name is Mike Mogul. I'm a meteorologist by training, a math tutor by choice. My wife is a certified elementary middle school math and science teacher, and we've been involved in education and learning for a long time. I've been doing it for 45 years, she's been doing it for 30 plus, and we're very concerned about what's going on in education today. That's the reason I'm producing this videotape, talking to you today about Common Core, which is nothing new. It's just repackaged bad education in a new cloak. Okay, talking about STEM for a minute. STEM is science, technology, engineering, and math, but clearly any area, whether it's really science, technology, engineering, or math, or reading, history, whatever, requires critical thinking skills. In STEM problems, you have to apply math. Math is the critical piece. It's the language of STEM. If you know how to crunch numbers, that's fine, but there are computers to crunch numbers. The key is, do you know how to piece the pieces of the puzzle together to figure out how things work, how a different equation or a different change in parameters can produce a more efficient car engine, can make sure that a rocket stays on track, can make aerodynamics better for cars and airplanes. Those are challenging problems. They don't come just because a student knows how to plug numbers into an equation. It's really important that the reality of the STEM program include real situations. So Dr. James Milgram of Stanford, who was on the Common Core validation team, commented on a lot of things that were missing from the Common Core program, and that's why he couldn't validate it. This included everything from it wasn't testable, it wasn't researched, and the list goes on. What I'd like to talk with you about today is what's going on in the textbooks in the public schools. And to do this, there's a lot of textbooks. And when I say public schools, I also include private schools, home schools, SAT exams, anything else that's out there focusing on Common Core. We'll key on the math today, of course, that's where I'm focused. To do this, I reviewed the Algebra 2 textbook produced by Glencoe McGraw-Hill, which is used in Collier County, Florida public schools. I did not find a lot of examples that focus on STEM problems or STEM situations. This is an Algebra 2 textbook. This is what's supposed to be getting kids ready for college. What I found is problems that don't excite the kids, are irrelevant to the kids, don't convey the information that the kids need to know, and even worse, the problems are just repetitive. It's the same problem over and over and over again on many pages with just different numbers. And to me, that's asking the kid to be ready for a standardized test. And that's where we've gone in math. We've focused on the standardized test. How do we do the problems? Not do we understand why we're doing the problems, and the kids don't learn the underpinnings of math that they need to know when they get to college. It's that simple. Colleges for years have been complaining that kids come to college unprepared to deal with the introductory algebra classes, calculus, pre-calculus, differential equations, other classes that the STEM careers require. What we're learning in schools now is so watered down, so incomplete, so lacking of any fundamental concepts. It's just, how do you crank out a problem and get an answer? So in going through the Glencoe Algebra 2 book, I came across this one problem. And since I have a weather background, this problem jumped off the pages at me. And what I'd like to do is share this problem with you. For reference, it's on page 481 in the Florida edition, just in case you have a copy. It reads, the equation for wind speed in miles per hour near the center of a tornado is given by this mathematical relationship, where d is the distance in miles that the tornado travels. So the first thing that you're asked to do is write the equation in exponential form, and that's a math translation problem. And then it talks about, in May 1999, a tornado devastated Oklahoma City, factual, with the fastest wind speed ever recorded, unfactual. If the tornado traveled 525 miles Estimate the wind speed near the center of the tornado. The problem with that is that there has never been an observed tornado in the United States, or anywhere in the world for that matter, that's exceeded 218 miles. So a 525-mile tornado, roughly the air distance from Atlanta, Georgia to Washington, D.C., is unfathomable and has no business being in this book. It conveys information to the students that tornadoes can be on the ground for 500 miles. So I went and checked with NOAA's Storm Prediction Center in Oklahoma City to see if the equation in this book had any basis in fact. Nobody that I spoke to could verify the equation. That being the fact, I decided to contact Glencoe Publishing to see if I could find out something about the history of this problem. I was fortunate enough to talk to an editor, and very pleased that he got back to me in less than 5 hours, and then proceeded to do some research on it. And I'd like to read you his response. I did some research and found that the equation for wind speed of the tornado was first placed in the 2010 edition of our Algebra 2 text. One of our editors remembered that for that edition, we did keep printouts of the web pages where we obtained application equations, but those have since been thrown out. I am not positive there would have been one for this equation or not. It is also possible, since those books were being written in 2008, if there was a website cited, that website no longer exists. It appears to me that it is more likely that the equation came from creating a logarithmic regression of a small set of data. The problem should state that this is a contrived estimate of the speed, if that even remotely implies, and the reference to the 1999 Oklahoma tornado should not be presented at all. I found online a reference to a similar problem that had the tornado traveling only 95 miles, and I'm wondering if the original numbers for the problem got changed. No matter, what is there is definitely in error. I will try to come up with a suitable correction for this problem going forward. Over the last few years, we have checked and/or rewritten the solutions for nearly every practice problem in all the high school textbooks. We have found and fixed many instances where application problems did not make sense, such as a boy kicking a football over 600 feet into the air. We have replaced formulas that we recognized did not seem to make sense because our knowledge of the subject or the answers it was giving. However, there will obviously be others on topics with which we are unfamiliar, and because the answers are correct, they will slip by us. It is our intention that the formulas and equations used in modeling problems are factual, or it is clearly stated otherwise. We do rely on our customers to let us know if a problem is incorrect or not factual. We greatly appreciate you bringing this problem to our attention, and as I said on the phone, please feel free to contact me with any other problems or concerns that you come across. This testimonial is important for many reasons. The first is that the editor admits that there's incorrect information and that other problems have had incorrect information. As a scientist, my question back to the editors is, where were you in all of this? I then take it one step further. The state approved the textbooks. Where was the state in analyzing these problems to see if they were factually correct or otherwise correct? And where is the Collier County school system in evaluating these books for such errors and inconsistencies? There's multi-levels of review here that should ensure that these textbooks are of the highest quality by the time they reach the students. Errata sheets buried on the internet, inserted into books, lost by students and teachers, is not the way to ensure factual information is there. That concerns me greatly. I know that when I went to college, I had to take all types of math classes in my meteorology field. In fact, when I went to college, I couldn't wait to take meteorology classes because by my understanding as a high school student, I wouldn't have to take physics anymore. Boy, was I surprised after I took 4 physics classes. But the physics classes became relevant. They were in something that I was interested in. It kept my attention. It got me to understand physics that I couldn't understand in high school because it was disjointed. It made no sense. It didn't have applications. That's what the students are faced with today. They have all types of problems in textbooks, especially in math, and the problems have no meaning to them. Certainly, we could have problems that students deal with that have to do with how fast somebody runs on a football team and how long it takes them to go downfield to catch a pass. We could talk about airplanes that travel various distances and what the effective wind speed is on the aircraft path length and fuel usage. We can talk about energy efficient cars. Does it make sense to buy an energy efficient car from a cost benefit risk analysis? We don't do that with our students. We simply teach them to do the computations. We have to do better, or we will lose this generation of students. We can't afford to do that. Not because the world rating system matters, but because what we do in this country matters. I don't care how we compare to India or China or any other country. I care how we do, period. That should be our rating system. So if you'd like to have a dialogue with me, and I'm willing to do it by email, phone, Google Hangouts, feel free to contact me. My contact information is on the screen. I will tell you, I'm not going to sit there and battle you in position papers. But if you want to have a dialogue and learn something about where I'm coming from and want to share something that I can learn from, I'm willing to do that. Most people won't. I'm giving you a chance. Please contact me. I have an open mind. Thank you very much.